Good afternoon, students. So in the previous class we learned the topic measurements of delta heights and delta U. How we can measure delta heights and delta U. Now listen, now we can see the next topic, relation between CP and CV. Relation between CP and CV. What is meant by CP? Heat capacity at constant pressure, and CV means heat capacity at constant volume. So relation between CP and CV. Relation between CP and CV. You know the formula enthalpy. The definition enthalpy height is equal to U plus PV. Enthalpy height is equal to U plus PV. Ideal gas equation, you know, for an ideal gas, PV is equal to nRT. Ideal gas equation, PV is equal to nRT. So listen, first consider the enthalpy formula. Enthalpy height is equal to U plus PV. You know the ideal gas equation, PV is equal to nRT. You just consider this is equation 1. Substitute this PV value in this equation. If you are substituting, tell the answer. Height is equal to U plus nRT. Height is equal to U plus nRT. You just consider this equation is equation 2. Now differentiate equation 2. Differentiate this equation 2 with respect to temperature T. Differentiate this equation 2 with respect to temperature T. If you differentiate this, you will get the answer. How we can differentiate? Differentiation symbol is just write dou height with respect to temperature. So dou height divided by dou T is equal to right side dou U divided by dou T plus N into R into T is there. So dou T divided by dou T. Understand? So you can cancel dou T and dou T. So you will get the answer. Tell the answer. Dou height divided by dou T is equal to dou U divided by dou T plus N into R into 1. Understand? Now listen. Already you know this formula. Dou heights by dou T and dou U by dou T. The two values already you know. See, already you learned this topic. Dou heights by dou T means that is dou heights by dou T is equal to that is CP, heat capacity at constant pressure. At the same time, dou U by dou T means that is CV, heat capacity at constant volume. Dou heights by dou T means CP, dou U by dou T means CV. Substitute these values. So we are substituting. Tell the answer. CP is equal to CV. CP is equal to CP is equal to CV plus NR. CP is equal to CV plus NR. Understand? From this, you just take the CV left side. If you are taking, tell the answer. CP minus CV is equal to N into R. Just to consider this is equation. This is equation 3. CP minus CV is equal to N into R. Understand? So this is the relation CP and CV. Relation between CP and CV is CP is equal to CV into NR. CP is equal to CV into NR. Understand? CV plus NR. Understand this? Now listen continuously. By using this equation, you can calculate delta U and delta heights. You can calculate the term delta U and delta heights. By using this relation, you can calculate the delta U and delta heights. How we can calculate this means, listen, you know the formula CV, heat capacity at constant volume. Heat capacity at constant volume. Separately take CP and CV. First take the CV formula. Tell the formula CV. CV is equal to dou U divided by dou T. Cv is equal to dou u divided by dou t. From this dou u means dou u formula. Dou u is equal to Cv into dou t. Dou and deltas are similar. So instead of dou you can take delta. So you write the equation delta u is equal to Cv into delta t. Delta u is equal to Cv into delta t. Understand this? See here, listen. Here delta t formula already you know. Delta t means difference between final and initial temperature. So tell the formula. Delta u is equal to Cv into T2 minus T1. Delta u is equal to Cv into T2 minus T1. Suppose if you are taking n moles of an ideal gas. Just consider n moles of an ideal gas. N moles means, can you tell the equation? Delta u is equal to n into Cv into T2 minus T1. N into Cv into T2 minus C1. This is delta u value. So by using the heat capacity at constant volume and constant pressure equation, we can calculate delta u means, tell the formula. Delta u is equal to n into Cv into T2 minus T1. The same way you can calculate the delta heights also. You can directly write the delta heights formula. Delta heights is equal to n into, instead of Cv you can write Cp. N into Cp into T2 minus T1. Understand? So this one only calculations of delta heights and delta u. How we can calculate this? First you know heat capacity at constant volume formula. Delta u by delta t. From this delta u means Cv into delta t. Delta t formula T2 minus T1. If you are taking n moles of ideal gas, formula delta u is equal to n into Cv into T2 minus T1. The same way you can write the delta heights formula also. Understand this? So first we learn the topic relation between Cp and Cv. Relation between Cp and Cv. By using this expression we learnt how we can measure delta u and delta heights. How we can measure delta u and delta heights. Understand this? Any doubt? See, now take page number 201. Just note the question. Relation between Cp and Cv. Relation between Cp and Cv for an ideal gas. So how we can relate this Cp and Cv? How we can relate this? This is one of the important derivation. Note the topic fully. From the definition of enthalpy formula, then ideal gas equation. So you can substitute this PV formula, then differentiate this equation with respect to temperature. Then this is Cp and Cv. If you are substituting, you got this answer. This is the derivation. Then continuously you can calculate delta u and delta heights. You can calculate delta u and delta heights. For 1 mole of an ideal gas, we have page number 202. Page number 202. Cv is equal to du by dt. Du by dt. From this du means Cv into dt. For a finite change, we can write delta t formula. You can write T2 minus T1. And if it is n moles of an ideal gas, delta u is equal to n into Cv into T2 minus T1. Same way you can write delta heights also. Just mark till this equation 7.26. This is one of the important 5-mark question. Relation between Cp and Cv. Cp and Cv. Understand this? Okay, listen. See, now we can see the next topic. Applications of heat of combustion. Applications of heat of combustion. The first application is calculation of heat of formation. First application, calculation of heat of formation. So you can calculate the heat of combustion of organic compounds. You can calculate the heat of combustion of organic compounds. You can calculate the heat of combustion of organic compounds from heat of formation of some other compounds. You can calculate the heat of combustion of one organic compounds from where we can calculate. This means we can calculate from some other heat of formation of some other compounds. Heat of formation of some other compounds. So you can calculate the heat of combustion of organic compounds can be calculated from heat of formation of some other compounds. So here we can consider one simple example. You can calculate the heat of combustion of methane. You can calculate the heat of combustion of methane. This is one of the organic compound. You can calculate the heat of combustion of methane. Heat of combustion of methane or heat of formation of methane. Heat of formation of methane. So how we can calculate this means? How we can calculate this means? From the values, from the heat of formation values of hydrogen, carbon and some more values, methane. So listen, we can calculate the heat of combustion of, we can calculate the heat of formation of methane. Heat of formation of methane from the values of heat of combustion of carbon, hydrogen and methane. Carbon, hydrogen and methane. By using these three values, we can calculate the heat of formation of methane. So how we can calculate this means? So listen, you just write the equation. First, you know how we can produce methane. Carbon reacts with hydrogen to form methane. How we can prepare methane? Carbon reacts with hydrogen. Carbon reacts with hydrogen to form methane. Here 4 hydrogen present, so you can write 2 hydrogen. So carbon reacts with hydrogen to form methane. So we are going to calculate this methane delta H value only. Heat of formation of methane. Heat of formation of methane. How we can calculate this means? From the values of carbon, hydrogen and methane. Carbon, hydrogen and methane. So listen, first you can consider some thermochemical equations. You can consider some thermochemical equations. What are the equations means? First, to produce water molecule. How we can produce water molecule means H2 bonds with the oxygen to form H2O. H2 bonds with the reacts with the oxygen to form H2O. 2 hydrogen present, oxygen 2 there 1. So you can write half oxygen. So H2 plus half O2 gives H2O. Understand? In this equation, your enthalpy, this value, delta H naught value, delta H naught is equal to minus 285.8 kilojoule per mole. Minus 285.8 kilojoule per mole. Understand? Same way you can consider another one equation. You can consider, see, already you know this topic, how we can calculate heat of combustion from the values of some other organic compound. So this is the first equation. Then second equation, carbon reacts with the oxygen. Carbon reacts with oxygen to form carbon dioxide. Carbon reacts with the oxygen to form carbon dioxide. So here you can write the value delta H naught is equal to minus 393.5. Delta H naught is equal to minus 393.5 kilojoule per mole. You consider this is first equation and this is second equation. Understand? So listen. We are going to calculate the heat of combustion of methane. Heat of combustion of methane. How we can calculate means heat of formation of some other organic compounds. Here we consider two organic compounds. Understand this? See, listen. Now the third equation, methane burns with oxygen. Third equation, methane burns with oxygen. CH4 plus O2. CH4 plus O2. Methane burns with oxygen to form. You will get the product carbon dioxide and water molecule. So you will get the product carbon dioxide and H2O. Carbon dioxide and H2O. Understand? See now carbon 1 present, oxygen here 2 present, but there 3 present. So you write here 2. So here 4, here 2. So here also 2. So 4 hydrogen, 4 hydrogen. Understand? In this equation, enthalpy of formation value minus 890.4. Delta H naught value minus 890.4 kilojoule per mole. Minus 890.4 kilojoule per mole. Understand? Understand? Then you can write another equation. You can write the reversible equation. The third equation you can write reversibly. If you are writing reversibly, can you tell the answer? CO2 plus 2H2O gives CH4 plus 2O2. You will get the answer, positive answer. Reversibly means 890.4 kilojoule per mole. Understand? Understand? So listen. Your question is, calculate the heat of combustion or heat of formation of methane. Heat of formation of methane. So we can calculate this means by using these three equations. By using these three organic compounds. By using these three compounds. Understand? Now listen. Already you know the first equation. You will get the first equation. See, you got the first equation, methane preparation. See here, this is the second equation. This is third equation and this one fourth equation. First we written one equation, methane preparation. Carbon reacts with hydrogen to form methane. Carbon reacts with hydrogen to form methane. C plus 2H2 gives CH4. So you can prepare this equation, this first equation, from these three equations. By using these three equations, we can write this, we can prepare this methane. We can prepare this methane. So just use this three equations, just add this three equations. Just add this three equations. If you are adding, see here H2 present, but here see, listen, just you can write this equation. Equation 1 is equal to, you can write the relation. Equation 1 is equal to multiply 2 into equation 2. Equation 2 into 2 plus equation 3. Equation 1 is equal to multiply equation 2 into 2 plus equation 3 plus, you just consider this is equation 5 plus equation 5. See, listen. First we learned the equation hydrogen plus oxygen gives water molecule. Carbon plus oxygen gives carbon dioxide. Methane plus oxygen gives carbon dioxide and water. You can write reversible equation, so you will get positive value. And already we learned methane preparation. Carbon plus hydrogen gives methane. So how we can write this equation means equation 1 is equal to equation 2 into 2. Reason, here half oxygen, that is the reason. So equation 2 into 2 plus equation 3 plus these two equations are same. Reversible equation. So from this you take any one value, we take on positive. So equation 2 into 2 plus 3 plus 5. So can you tell the equation? First equation 1 is C plus 2H2 gives methane. You will get this answer. So we can write this relation. So we can write this relation. Tell the answer. First equation 2 into 2. Equation 2 is H2 plus half O2 into 2. Into 2 means 2H2. Here this one into 2 means O2. So you will get the answer 2H2 plus O2. 2H2 plus O2. This one left side. 2H2 plus O2. Then third equation C plus O2. C plus O2 plus fifth equation CO2 plus 2H2O. CO2 plus 2H2O. Understand? Now gives a right side. Right side, can you tell the answer? Right side first equation H2O. This one into 2. So 2H2O plus next third equation carbon dioxide CO2 plus last fifth equation CH4 plus 2O2. Understand? Can you cancel any terms? You can cancel this O2, O2, 2O2. So here 2O2. You can cancel CO2, CO2. You can cancel 2H2O, 2H2O. Can you tell the answer? 2H2 plus C gives CH4. You can write the equation correctly. Carbon plus 2 hydrogen gives methane CH4. You know this is equation 1. Carbon plus 2 hydrogen gives methane. Understand? Understand? So listen. By using these three equations, second one, third one and fifth one, by using these three equations, we can derive we can find the equation 1. Understand this equation? Okay, see now listen. See now we got this equation and we can substitute the value. See, from this equations we can calculate the enthalpy of combustion. This enthalpy of formation of methane. Enthalpy of formation of methane. So you consider this is X. You consider this one is X. So can you tell the answer? Equation 1 is X is equal to equation 2 answer already we learnt. Delta H naught value minus 285.8. Minus 285.8 plus equation 3 value will get minus. So minus 393.5. Minus 393.5 plus equation 5 890.5. 890.4. Understand? Tell the answer. You will get the answer. Minus minus. So tell the answer. Minus 285.8 minus 393.5. Add this. If you are adding, you will get the answer. 3, 4, 9, 7, 6 minus 679.3. This one plus. So 890.4 minus 679.3. So tell the answer 1, 1, 1, 1. So sorry, one more time listen. See, you know first equation delta H naught value X. We are going to calculate this one only. X is equal to equation 2 into 2. There we applied equation 2 only, that answer only, but equation 2 into 2. Equation 2 value you know minus 285.8. Minus 285.8 into 2 plus equation 3 delta H naught value minus 393.5. So minus 393.5 plus equation 5 answer 890.4. 890.4. First multiply this 2. Minus 285.8 into 2. See, first multiply this into 2. If you are multiplying this, tell the answer. 16, 10, 11, 16, 7, 4, 5. So tell the answer. Minus 571.6 minus 393.5 plus 890.4. If you are adding this 2, tell the answer. First, minus 571.6 minus 393.5. So 11, 4, 5, 6, 8, 9. Minus 365.1 plus 890.4. So you will get 11, 4, 7, 4, 5, 7, 7. So your answer X value 74.7 kilojoule per mole. 74.7 kilojoule per mole. So you got the answer. Enthalpy of formation of methane. Enthalpy of formation of methane value 74.7 kilojoule per mole. Understand? So how we got this value? You can calculate this enthalpy of formation of methane from some other compound. Some other compounds means what are the compounds? Carbon, hydrogen and methane. From this values we can calculate the enthalpy of formation of methane. Understand this? So this is the first application. Applications of heat of combustion. So your first application, calculation of heat of formation. Calculation of heat of formation. Understand this? Okay, now see the second application. Second application, calorific value of food. Calorific value of food. What is meant by calorific value? Calorific value means that is defined as amount of heat produced in calories. Amount of heat produced in calories. Amount of heat produced in calories when 1 gram of the substance is completely burnt. When 1 gram of the substance is completely burnt. So calorific value means amount of heat produced in calories. Amount of heat produced in calories when 1 gram of the substance is completely burnt. When 1 gram of the substance is completely burnt. And here the SI unit is SI unit of calorific value. SI unit of calorific value. Joule. SI unit of calorific value. Joule per kilogram. The calorific value SI unit. Joule per kilogram. And usually this one is expressed as. Usual expression is. Usually this one is expressed as calories per gram. Calories per gram. So listen, SI unit joule per kilogram. Usually this one is expressed as calories per gram. Understand? So this is the second application, calorific value of food. Calorific value of food. So calorific value means amount of heat produced in calories when 1 gram of the substance is completely burnt. When 1 gram of the substance is completely burnt. SI unit you know joule per kilogram and usual expression calories per gram. Understand? And totally 2 applications we learned. What are the application? First one, calculation of heat of formation. Calculation of heat of formation. There we learned we can calculate the heat of formation of organic compounds from the values of, from the heat of formation of some other compounds. Heat of formation of some other compounds. Then second application, calorific value of food. There we learned calorie. What is meant by calorie? Then SI unit and usual unit. Understand this? So this is the applications of heat of combustion. Understand this topic? Okay, listen. See, now take page number 205. Mark the application. Applications of heat of combustion. Their first application, calculation of heat of formation. Just note the topic. Heat of combustion of organic compounds can be determined by using formation of some other compounds. One example they taken, heat of formation of methane from the values of combustion of hydrogen, carbon and methane. The values they given and they given the example, equations they given. First, methane formation, you are going to calculate this one only. From this equations, from this values. What are the values? First, water molecule preparation, you got this. Carbon dioxide preparation, carbon dioxide plus water molecule, you got this values. You got this 3. And here in the last one, we can write the reversible equation. They return the reversible equation. If you are writing reversibly, you got the answer plus. Then you can calculate this x value. How we can calculate this x means from this 3 values. So see the relation. Equation 1 is equal to equation 2 into 2 plus equation 3 plus equation 5. So equation 2 into 2 is this value into 2 plus equation 3 plus equation 5 value. If you add these 3 values, you will get minus 74.7 kilojoule per mole. Understand? Then page number 206. They return the answer. Heat of formation of 1 mole of methane is minus 74.7 kilojoule. The same answer only they given. Heat of formation of methane minus 74.7 kilojoule per mole. Understand? Then second application, calculation of calorific value of food and fuels. Calorific value is defined as amount of heat produced in calories when 1 gram of the substance is completely burnt. And SI unit they given joule per kilogram, and usually this one is expressed in calories per gram. Just a note till this per gram. This is applications of heat of combustion. And here 1 calorie is separate 2 more question. If your question 1 calorie, note the answer. Calorific value is defined as amount of heat produced in calories when 1 gram of the substance is completely burnt. Till this, you just note the answer. This is important 2 more question. Understand this? So, totally we learned the topic today. First page number 201. Relation between Cp and Cv for an ideal gas. Relation between Cp and Cv for an ideal gas. Next we learn applications of heat of combustion. So your next day's homework, this 2 topic only. Relation between Cp and Cv, and another one topic, applications of heat of combustion. Understand this? Okay, see now take page number 224. Page number 224, question number 35. Question number 35. Define the calorific value of food. What is the unit of calorific value? What is the unit of calorific value? Page number 206. Page number 206. Note this paragraph fully. Calorific value is defined as amount of heat produced in calories when 1 gram of the substance is completely burnt. SI unit joule per kilogram, and usually this one is expressed in calories per gram. Understand this? Note this topic and learn the homework portion thoroughly. Any doubt? Okay, thank you.